Hey everybody, it's Tony from Adafruit, and I wanted to do a live stream on using Circuit Playground with Adafruit I/O. So Circuit Playground is the all-in-one Arduino compatible electronics learning board. It's basically like a little Arduino with all kinds of components and things embedded on top of it. And I've done a lot of video streams, and if look below in the description when this video goes up on YouTube, and I'll put a link to a whole series of videos on different Circuit Playground streams and things. But I wanted to look at how to use it with Adafruit I/O, which is kind of our Internet of Things service that makes it really easy to create a dashboard and control devices and things over the internet. And just wanted to play with, what is the intersection of using Circuit Playground with Adafruit I/O. Now, Circuit Playground doesn't have like a Wi-Fi microcontroller. It can't directly talk to an internet service. But by using the Firmata firmware, which I've done a bunch of videos on, and that's a firmware that you load onto the Circuit Playground board, it's just an Arduino sketch really, then that allows your computer to control Circuit Playground. So your computer can tell Circuit Playground, turn on the lights, or read some of the sensors, or play a tone on the buzzer. And so because of that, then you can run code on your computer that talks to a connected Circuit Playground board and controls it. And once you're running on your computer, then you can talk to internet services, you can talk to Adafruit I/O, you can talk to if this then that, you can go crazy, go wild with it. And I have a feeling that I'll probably end up doing more videos on this kind of a topic because I think it's a really interesting, kind of powerful thing. It's just using Circuit Playground as a real simple, all-in-one, ready-to-go board that you can just plug in to your computer and then have like a Python script that runs and does internet things. So talks to Adafruit I/O, maybe makes like, listens to a dashboard and changes the color of pixels and things. So that's what I wanted to show. I'll do a quick little demo of what I'm going to build on the stream, and then we'll just dive into it. And you'll see that the code's not super complex, and I'm going to gloss over some stuff and maybe point you towards other videos where I've talked more in depth about like Adafruit I/O and Circuit Playground and stuff like that. But let's just see what I want to do in this stream. So let's go to the main kind of workbench view. Well, I guess desktop view. We'll do this. So you can see here in the upper right hand corner, this is Circuit Playground. So again, if you're not familiar with it, take a look down in the description. I'll have a link to the board on Adafruit's site. But it's basically an Arduino compatible, and it has a ring of NeoPixels along with all kinds of sensors and things embedded on the board. You don't have to solder any of this stuff. It all just comes out of the box like that. You can see a couple pixels lit up. And over here is Adafruit I/O, and like I mentioned, this is kind of our Internet of Things service. We've done a lot of videos, have lots of tutorials and guides on it. It's kind of in a beta version right now where you can sign up, get access, and you can create a dashboard where your dashboard has different feeds and controls and things on it. So I have two different controls here that talk to two different feeds on Adafruit I/O. And a feed is just like a data source. So you can set a value to a feed, your devices can read values, like I have a script that's running in the background right here, actually it's a Python script, and it's listening to the changes from the two feeds on this dashboard. And when it detects a change, like in pixel count, let's see what happens. I'll drag this over to 9. Then you can see, look, 9 pixels are lit up. So there's one right here that's not lit up because there are 10 pixels total on Circuit Playground. So if I drag this over to 10, then that lights up, and I can drag it all the way down to 0. And you can see, like, this is pretty quick. Like, as soon as I drag this thing, there's events being sent around, things are changing, and it's quick to change. Now you can change the color also, so we have a color picker, and we can say, like, let's go for like a pinkish purple color, and look at that, it lights up the color. And again, I can just change the count of pixels that are lit up, and it all happens pretty intuitively, pretty easy to use. Maybe make like an orange type color, so you can see it lights up like that. So this works pretty well. It's a pretty simple, I think, example of using something on the internet, because this dashboard is a web page that's being served from io.adafruit.com. This is Adafruit server. And what happens is when you change these controls on the dashboard, that's actually using a technology called MQTT, the Message Queue Telemetry Transport, I believe is what it's called. It's basically an event system. So, by dragging this slider, that's creating an event that says, hey, the pixel count feed changed to the value 2. And then my script in the background right here is actually listening for changes to that feed And you can see right here it got this change, and there's actually a bug with my account. I'm getting double messages. You won't notice double messages, but it doesn't really matter for my purposes here. But you can see, hey, it got that new value, and same thing happens when I change the color. So if I change the color in the picker here, that's sending a message or an event that says, hey, the pixel color feed just changed to this green color. It's actually the hex color code down here. And I can see right here my script received it. And then once my script receives this new event, it can do anything. So it's actually telling my Circuit Playground board, okay, I just received the green color and I know that 2 pixels should be lit up, so go light up 2 pixels with the green color. Or, you know, when I drag the slider up to like 10, then it's getting an event that says light up 10 pixels. And so it tells the Circuit Playground board, okay, light up all 10 pixels with the green color that I saw before. So that's what I want to create in this stream real quick, is just show an example of how we can create the code to listen to an Adafruit IO dashboard for the pixel count and color, and then talk to a Circuit Playground board that's running the Firmata firmware. So let's just kind of dive in and we'll just start coding and see how this works. Now, as some setup, you do need to have Circuit Playground, and it needs to be running the Firmata firmware. And I've shown this a bunch of times. If you load the Adafruit IO Circuit Playground library, which actually I should have put up here. Wait, let's put GitHub here, get the right link. There we go. So this Adafruit _ Circuit Playground, search in the Arduino library manager for Circuit Playground, and you should find this library. And in here, there's an example called Circuit Playground Firmata, and just load this onto a Circuit Playground as is. You don't need to modify anything. And then once it's loaded, you're good to go with using the Circuit Playground Firmata code. Now, the Circuit Playground Firmata code, I should have put a link up here also. We'll say Circuit Playground Firmata. So that's this GitHub repository. And again, these links I'll put down in the description when this goes up on YouTube. But you want to download this repository because it has basically the Python code that we need to start talking to Circuit Playground. And it mentions in the README here, there's a little bit of setup you need to do. You need to run this pip command to install the Firmata library, because that's what my Firmata code uses, my Python Firmata code uses to talk to Circuit Playground board. So once you do that, then you can test out some of the examples. So this has a bunch of examples and it describes them down below here. And actually I do have a guide on this that I just remembered. So we'll say Adafruit Circuit Playground Firmata guide. And so this is actually probably what you want to look at first if you're totally unfamiliar with Circuit Playground and Firmata. This will walk you through, I've actually got a whole video on it, how to load up Firmata and run some of the basic demos. So do that first. Make sure that you can actually talk to Circuit Playground and control it with Firmata. And then we'll kind of get started here. So, okay, what I'm going to use is a Python library called IO Client Python. And again, I'll put a link to this. This is basically our official Adafruit IO Python client. And it mentions here how to install it. So you can pip install it from the Python package index, or I usually recommend downloading it from the source here, because when you install from the Python package index, you don't get the example files because I don't know of any like common place that Python packages are meant to have example files, which kind of sucks. It'd be nice if they had a concept of examples. Like you can have ancillary data files, like, you know, a config file, and you can choose where to put that thing. But, you know, where do you put examples? Like on Windows, you know, where would examples go? Does it go in like your home directory, which you don't even really kind of have, put on your desktop? But then on Mac OS X, where does it go? And where does it go on Linux? So I don't know, something for the Python people. It'd be nice if libraries had a concept of examples. Anyways, rant for another day. So the examples are pretty useful because these are real simple, easy examples that I'm just going to use and modify and use that to get started here. So you do want to clone this repository, I'd recommend, and then install it using kind of this manual install method. So run the setup.py install command, and that'll get basically everything that you need to use this library. And that's what we'll do to start with. So in the library, there is this mqtt subscribe.py example, and again, it's in that examples folder, so you'll want to download it from GitHub here if you got it from the Python package index. And this is basically the real simple example of how to subscribe to a feed in Adafruit IO, listen to changes, and then just print them out basically in here. So I'm going to use this as a base, and then also in the Firmata Python examples, and that's what I have open here is the Circuit Playground Firmata library. That's this GitHub repository, so this Circuit Playground Firmata one. So I have this open, and in the Python examples here, you know, the pixels.py is the basic example of using the neopixels. So this just animates the neopixels. So I was thinking maybe I'll start with this as a base. Oops, let me just select everything. And then let's make a new one. Now I've already made a file, but I'm just gonna start from scratch so I can kind of show you, you know, my thought process as I kind of code this thing up. So, okay, so we'll start with the pixel.py as a base. And I'm gonna delete everything after pretty much just creating the board. So I'm gonna stick with the boilerplate that the script starts with, where it will parse out the first command line parameter because basically it's looking for what serial port to connect to. And then once it gets that, it creates this Circuit Playground object, and then that has all kinds of functions, like if you want to set the color of a neopixel, or if you want to, you know, read the sensors. So I'm just using this boilerplate basically to get a board that I can talk to. And then I'm going to grab from the, actually I'm going to close that, that's the one that I created ahead of time. From the MQTT subscribe example, so remember this is from the Adafruit IO examples now, so I'm kind of mashing together two example files here, which is not a bad way to do it, you know, this is basically all I need. So I'm just going to start copying out some code from here. Maybe we'll start with this stuff at the top here. This is mostly like the imports and the configuration. So I need to import the Adafruit IO library, that's this line right here. Now for Circuit Playground, I don't have the Firmata code installed as a library. I haven't really created a proper Python library for this yet. So this line right here from Circuit Playground, import Circuit Playground, that's basically looking for this circuitplayground.py file in the same directory. So you have to have this aio.py in the same directory here right now. Maybe in the future I'll make this a proper Python library so you could install it globally and use it. But for now, you just need to make sure that anytime you use this import Circuit Playground, you have to have a circuitplayground.py file in that same directory. So a little gotcha there. And then now I need to do a little bit of config. So to talk to Adafruit IO, you have to have a key. And so again, if I go back to this dashboard, if I press this thing, it's going to show me my secret AIO key. I'm not going to do that on the stream here. It's just a big string of numbers. And so you need that when you talk to Adafruit IO because it's kind of the authentication token. And if you need to, like, you can regenerate it. Like if you accidentally did a live stream and showed your key, you know, you could create a new one, so it's not the end of the world. But it's just a basic form of authentication to say this is who the user is that's trying to contact the service. So I need that, and I need my username. And it mentions here, you can go to accounts.adafruit.com to see your username. There's no harm here. I'm going to say my username is tDecola. Now for my Adafruit IO key, you're probably thinking, oh man, we're going to get to see his key, and we're going to wipe out his account. But no, I was actually thinking ahead of time. So what I'm going to do, I stored this in an environment variable. So, you know, I can actually do like export foo equals bar, and then if I echo foo, you can't do this on Windows, unfortunately, because Windows, well, you can, but man, I can't remember the syntax for environment variables on Windows. I'm sorry. Look them up. I'm sure there's a way to figure it out, but it makes a little more sense, I think, in the Linux and Mac world. So anyway, so you can see I just set this environment variable foo to the value bar. And when I do this echo $, it's telling bash that I want to print out the environment variable named foo, and so you get that value. So that's cool. So ahead of time, I actually created an environment variable in this terminal session. And this environment variable, it won't last forever. It just lasts as long as this terminal session is open. I'd have to put this into like my bash profile if I wanted this to always be set. But anyways, I set ahead of time my Adafruit IO key in an environment variable. So I'll just have Python read that. So it's really nice. You can use the os.environ, and it's just a dictionary. So AIO key is what I set ahead of time. So it's just going to read from the environment variable the value of the AIO key environment variable and store that as my Adafruit IO key. So nice little clever way where I don't have to show the key here. I'm a little more secure than just directly copying the key into my source code here because, you know, maybe I check this into version control and then suddenly I've got my key in version control, and it's not good enough to just change the file because you have the whole commit history so people can go back. You actually have to, I think you still have to completely delete an entire GitHub repository if you accidentally commit like a secret there that you didn't want to get out, because you have to wipe out the whole history. So it's not good. You don't want to do that. But anyways, okay, so I've got those values set. Now I'm going to create a few more variables. So I need a feed for color and for count of pixels. So I'm going to create two variables for this. And for the color feed, I'm going to call this cplay pixel color. And then for the count, I'm going to call this cplay pixel count. And so these will just hold the names of the feeds that I'm going to read. And that's basically what I've hooked up on my dashboard here. And I'll go back and I'll actually create a new dashboard just to show you how to do this from scratch also. But you probably want to look at, I'll put in the description below, maybe some links to some Learn guides that give you a little more beginner look at like what a dashboard is, how to create one and stuff like that. But I'm going to kind of go quick through this example. So, go back to those other videos and guides to learn more. Okay, cool. So I've got these. And now, and let's see, I'm going to keep this code here where I set up my Circuit Playground board. So let's go back to the MQTT subscribe example. And it was basically just setting the name of the feed right here. So now the next part is basically this whole block of code here. Actually this whole thing. We're just going to copy all of this out. We'll go through this and I'll show you kind of what this code does. So I'm going to copy all this code and I'm going to paste it in here. So what's happening here, I'm basically creating three callback functions. So I'm making functions that the MQTT library in Adafruit IO or the MQTT client will call when certain events happen. So there's a connected callback. This gets called whenever the connection to Adafruit IO is created. So this is a good place to subscribe to feed changes or do any actions that require like knowing that you're connected to the service. And in this case, it just prints out, and I realized that this is not Python 3 compatible, so we'll make that Python 3. So this just connects, and originally it listened to this demo feed, but I'm going to change this because I'm not using that demo feed. So I'm just going to have it print out that, hey, I've connected to Adafruit IO. It's good to do that so I know that I'm connected. And then I will have it subscribe. So you can see once you're connected, you can call client.subscribe. So by subscribing to these two feeds, then my Python code will be notified whenever those feeds change, like when I change them on the dashboard. So let's just grab color feed and subscribe to that, and then do the same thing for the count feed. Okay, so we subscribe to that, and it's not demo feed. We'll say subscribe to changes on feeds. Okay, so that's good. The disconnected function, this will be called whenever you disconnect from Adafruit IO, either explicitly or maybe accidentally, or like there's a timeout interval. Sometimes, if you don't do a lot of actions, you'll get disconnected. And in this case, I just have it print out and say, hey, you've been disconnected. And then I call sys.exit, which just stops your Python program, which I think makes sense. It just tells me something went wrong and it quits. And then the message event, this gets called when a new message is received from a feed. So like when I change, this slider value here, that's going to send a new message, and that will actually call this message callback. And it's going to pass a few parameters. Client is just the Adafruit IO client object, so you can use this if you want to like subscribe and unsubscribe to feeds and things. The feed ID is a text string with the name of the feed. The payload is a text string with the actual bytes of the data that was sent in that feed. So if it's like the pixel count, then you get back, the number like 4 or 10 or whatever. If it's the color, you get back a string that's the hex color. So like this #48FF00, for example there. So that's what will happen when something changes. Now for now, this is just printing out the name of the feed and the value that it received. And that's okay. I'll keep that for now because I basically just want to, slowly iterate on this. So I'll first run this. It's not going to talk to Circuit Playground. It's just going to connect, and then it's going to print out the changes when it gets them. And that's good enough. So we'll start there. Okay, so then once I've defined my callback functions, now I have to create an MQTT client instance, and here's where I pass in the username and the key. And then I have to actually set up those callback functions. So I have to tell my client, the onDisconnect callback that you should call is this connected function up here. And the onDisconnect is the disconnected function right here. So that's basically just what this part does. I'm just hooking up those callbacks that I defined above and just telling my client instance, these are the functions you should use. Then I call connect, and that's just going to go and kick off the MQTT connection process. And once I'm connected, so this is actually just going to immediately move on. It's not going to wait for me to connect. So it's not a good place right here to put code where it's like, okay, now I'm connected. when you want to do something when you're connected, put it in your connected callback, because this is actually what's going to be called once you're connected. So that's what I'm going to do there. And then this client loop blocking. So this is basically because all of this MQTT stuff happens in the background. You know, these are asynchronous events. So my script, it doesn't know when a client or when a feed is going to change. You know, the only time a feed changes is when I physically move a slider or, you know, change the color here. And that could happen at any time. So I need some kind of a loop in my program here that's just waiting for these events. So it's just sitting in the background and just asking Adafruit IO, like, do you have anything new? Do you have anything new? And it's not actually asking, like that would be polling. It's actually just sitting there waiting with this MQTT connection open for Adafruit IO to send a new event down. So kind of Adafruit IO pushes those events down to the client code here. And when it receives them, then the code comes alive and says, oh, I received a new message, and oh, I know that this user defined this message callback, so I'm going to call their message callback, and I'm going to send them the feed and the payload that I received and all that stuff. So that's what happens in the background. There has to be some message loop. Now in the MQTT subscribe example, or maybe I don't have it in this example, but I have it in some of the other examples, there are a few different ways that you can do this message loop. Loop blocking is the easiest. This will actually just run the message loop itself, and it will never return. So, you know, if I put like print hello world right here, this will never execute because this call is blocking. So the execution will never leave this function because it just goes into an infinite loop waiting for these events. But I do have different versions. I have a loop background, I want to say I called it, where that will create a thread in the background that will run this message loop, and then your code will return, and you could put other things down here if you wanted. Like you'd probably want your own message or your own loop inside of here that's just, you know, doing other things in the background from that. So just a little thing to be aware of. In general, start out simple. So just use this blocking functionality because my code doesn't need to do anything else. It's only when it receives like a new message will I actually have to go talk to my Circuit Playground board and change the state of it. So, okay, so let's save this and let's run this script. So I'm going to run python aio.py. I have to point it at the serial port that my Circuit Playground Firmata board is connected to. So I'm just going to grab the name for that, so aio.py. And it takes it a second, so when it does anything with Firmata, the PyMata library has like a little boot up, well, not really boot up, but a startup process. But okay, you can see connected, and when it connects, it turns off all the lights and things. That's expected. And it says connected to Adafruit IO. Now, if I go back to my code, that happens when the connected callback function is called. So I know that I must be connected to Adafruit IO, and that probably also subscribed to those two feeds that I have up here. So let's go in and let's see. Now, I've already created this dashboard ahead of time, but I'll just go through and I'll show you the creation process. So I'll create a new dashboard. We'll call this Circuit Playground Pixels. And a blank dashboard is what you get what you get to start with. I'm going to click the plus to add a new block. And then let's start just with the slider. And so this, I chose the slider block, and then here it's going to show me a list of all my feeds, and I have a lot because like I've done a lot of testing and hammering on Adafruit IO, so you probably won't see these things. But I already have these feeds defined ahead of time, so I have a count and a cplay pixel color feed. If you don't have those feeds, you can just type them in here and click create, and it'll make a new feed, and so that's exactly what you can do. Since I have these, I'm just going to choose the count one. And then here I can kind of tweak like the title, so we'll say pixel count. I can change the range, so I want to go from 0 to 10 because there are only 10 pixels on the Circuit Playground board right here. The slider step, so it's going to move in units of 1. And then label, I don't know if we use this. I'll put pixels here for now. So yeah, I don't think we use this one right now. Okay, so now I've got this on my dashboard, and let's see what happens. I'll put, you know, here's the connected script in the background, and maybe if I slide this over a little bit, and let's see if I change this. Hey, look at this. I received the new value 8. And remember, I'm getting double messages because my account's in a weird state. You shouldn't see double messages if this is if you're doing this yourself. But this is cool. So you can see that's working. So let's add another block. Let's add the color block. So we'll go down. Color picker down here is the one that I want to do. So I'll grab this. And again, have to pick the feed. And remember, from the code I defined ahead of time, my color feed is cplay pixel color, so all with dashes, and I've already defined one ahead of time, so I'll just pick this guy right there. So do that, next step, and then I just set the title here, so we'll say pixel color, So that's all good. Okay, cool. So I've got that, and then let's just try changing this. So we'll change the color, and then I can see, yeah, cplay pixel color, receive the value, # FF6 C600. So everything looks like it's working great there. And again, ignore the double messages. That's a bug with my account. Okay, cool. So let's put the code in to change and control Circuit Playground. And it's actually pretty straightforward to do this. So what I wanted to do, basically, in this message handler, this is where I need to detect that the cplay color feed and cplay count feed have changed, and then do something with that. So I'm going to put an if statement in. I'm going to keep this print statement because this is useful. I can at least see, when these feeds change, and that helps me debug a little bit. But I'll say if my feed ID equals the cplay, or I think what did I call it? It was the color feed, we'll say. So we'll start with the color feed. Oops, I did not want to do that. There we go, copy. Okay, so if the feed ID equals my color feed, then I know that this event is a color event, and the payload value should be like a # hex R, hex green, and then hex blue value for the color here. So I'm going to have to parse those values out, basically. And I'll show you how to do that. So first I just want to check, so I'll say color feed changed. Now parse out the color value. Because when I set the color of pixels on Circuit Playground, I can't just send it this string hex color value. I have to send it numeric values like red equals 255 or green equals 128 or whatever. So I have to convert these from hex to decimal. But Python makes it super easy. I'll show you. It's awesome. It's one of the things I love about Python is how easy they make a lot of these common things. Okay, so I'm going to have to parse out, I know, like the red, but before I parse it out, I'm just going to do a little bit of defensive programming here and say, let's check that I actually have a value in payload. So first, check that payload has values which might be hex colors. So I'm going to check and say, like, if payload is none, or if the length of payload is less than 7, then just exit out of this function. So this is like a little guard that says, if for some reason something sends a null value or an empty value, or something that has less than 7 characters, because if you notice this # plus the 6 characters, that's 7 characters. If I get something with less than 7 characters, I know for sure it can't be a hex value because these are 0 padded, like it's always going to be 7 characters long inside of here. So I'm just going to stop processing, just going to exit out of the message function. I'm effectively just going to ignore that message, which is smart because now I can know in this part of the code, if I've gotten past this check, I have a good, maybe not good, but I have a payload value that I can at least start grabbing characters out of and parsing as hexadecimal. So let's do that. We'll say the red component equals, and here's how you convert from hex string to decimal value, like the base 10 or integer value. You just use the int function and you pass your string, so payload. Now from payload, I only need to grab the first 2 characters here, and it's actually character 1 and 2 if you're 0-based index. So your # is character 0, character 1 is F, character 2 is F. So I want those 2 characters, which means I'm going to use the slicing syntax in Python. So start from index 1 and go up to index 3, which sounds a little counterintuitive, but basically Python will grab everything from index 1, index 2, and then it's not going to grab index 3. It goes up to index 3, but it doesn't actually grab that index 3 value. So this is going to grab 2 characters. It's going to grab this FF value right there from the feed. And then the magic thing to tell it that this is hex and it should convert to base 10 is you give it the base. So I give it 16 right here, and then it'll do the conversion. So I can do the same thing for green, and then this time I want to go from character 3 to 5. So I want to grab 2 characters, the next 2 characters basically. And then blue I want to grab from characters, payload, 5 to 7. So we'll grab those. Oops. And again, base 16. Okay, so I've got my values there. And maybe just to be nice, let's just print them out to make sure we're getting good values. So say red equals, green equals, and blue equals. And then format, format. Man, I can't type today. Okay, red, green, and oh boy, there we go. Live typing. This is fun. I never did learn to touch type, but after like 15 years of professional development, I'm a pretty darn fast typer now. Maybe I wouldn't say pretty darn fast. Like professional typers are much faster, but I definitely, for the hunt and peck method, although I don't even really hunt and peck, I guess, anymore, you know, it's for a non-structured form of typing, I've improved my skills a bit. Okay, anyways, red, green, blue, I'm going to print those values out. And then for now, let's just do that. We'll just make sure I'm parsing these correctly. And then let's add a little else if. So now, else if the feed ID equals my count feed. And so this is going to parse out the count of pixels to turn on. And so this is actually pretty easy. I'm not even going to check the payload. I'm just going to say, you know, my count equals convert to integer the payload. Oops. And so if this has like a none value or something, it's going to throw an exception. It's just going to fail the whole program, which I think that's fine. So, and then maybe let's just print this out. So we'll say count equals, and then, 0 is what I want. We'll say format count. Okay, so let's save that. And then let's run this script. And we should see, hopefully, that now when I change the values, especially the color, I should be able to see that they're parsed out as red, green, blue color values. So, okay, we're connected. So let's just save the color. So there we go. So just save 255, 198, blue 0. That sounds about right. So the hex code here is FFC6. FF is 255 in hex, so that looks right. 198, that's pretty high, which sounds like C6. So I think we're looking good. And 0 is 0. So that seems good. And then count, just make sure we get the count. Yep, count equals 7. Okay, cool. Now let's actually control our Circuit Playground board. So what I wanted to do for this, I'm going to create a couple global variables. Maybe not the best way to structure things. Like all of my state in this script is just in these global variables right here. You know, when your scripts get really big and complex, it's a bad idea to put everything in global variables because you just have all this state. It's hard to understand what's going on. You know, it's better to probably create some kind of a class that has these as member variables. Anyways, that's a rant for another day. This is a simple script. You know what? It's going to work to do globals. So I'm going to keep track of my current color, and I'm actually going to initialize it just with like an initial 000. So this is going to store the red, green, blue component color values. And then count. I'm just going to initialize this to like, you know, the store the count of lit up pixels for Circuit Playground. Okay, and then I'm going to make a little function. We'll say update pixels. So this will basically just turn on count pixels with the specified color. And so this is just going to read from these two global variables right here and turn on that number, you know, count number of pixels to the specified color. So then down in my message handler here, as long as I just change the value of this color and count global variable and then call update pixels, that should do all the logic and make the pixels light up. So to do this on the board class, I want to call some functions. And if I go back to this pixels.py example, you can see like you can call the set pixel brightness, you can call the set pixel function, which you give it the number of the pixel and then the red, green, blue color values. And then you can call show pixels to actually change all the pixel colors, because set pixel will just change the pixel in kind of a memory buffer, and then show pixels will actually light up all the neopixels to that color. So it's nice that if you're animating things, you can change everything in memory and then just call show pixels and it will push them all out at once. So you won't see like flickering or weird, you know, update artifacts because of that. So that's what I'm going to do here. Basically, I just need to loop through count number of pixels and light them up the specified color. And before I do that, I first want to call clear pixels because that's going to turn all the pixels off, make them all just like black or, you know, not lit up at all. And then I want to go for I in range. You know, this is a standard little for loop in Python, and my range of values is count. And the nice thing is, you know, this count variable, Python's going to look and see, you know, I don't have a count defined inside this function, so it's going to use the count global variable right here. But again, that's the reason not to use globals, because it's not really obvious that this function depends on these two global variables right here. So if I come back later and change these, I might break this function without realizing it. So that's a little danger. That's why I keep mentioning it, is because normally you don't want to do this, but for simple stuff, it's fine. Okay, so go through and then call board.setPixel, and I need to say, okay, pixel I. So this is basically going to say, you know, if my count is 4, it's going to loop through from 0, 1, 2, 3, and then it's not going to do 4, because that's the way the range function works, is it goes up to the value you specify, not including it. So, you know, value 4 is going to give me pixels 0, 1, 2, and 3. So it's 4 pixels, but it's just from index 0 up to 3. And that's perfect. So that's just going to light up, you know, around the board, as you saw. Like, you know, value 10 is over here, and pixel 0 is right up here. So we're just going to light up all around the board the number of pixels. Now, the color that I want to pick, it's in this tuple right here, or tuple. That's 3 different values. And so I can grab those. I can just say color 0. That's going to grab, oops, the 0, the first value, color 1, and then color 2. So it's like you're using an array. Tuples or tuples are really powerful, one of the best parts of Python. So I'll grab those colors, that's going to set them all, and then the last thing I need to make sure that I call show pixels, because I've changed the pixels and now I need to tell the board, okay, light up all these pixels that color. Okay, so that's my update pixels function. That's pretty easy. Now in my message handler again, so I've parsed out my colors. Let's just change these. Now to change these global variables, one thing in Python, when you write to a global variable in a function, you have to explicitly tell Python that you're using that global variable. So here I need to run this global color command, which says, okay, now I'm going to change the color variable. So I'm going to set it equal to red, green, blue, like a new value here. And that's going to tell Python, don't make a local variable called color and set it to this value. Instead, because I said global color here, go back up and find this global variable color and change its value. And so that's why I'm doing this. If I didn't have this global color line here, this wouldn't work at all. Like, it would just be changing this local variable, which is not what I intend to happen, because my update pixel function, it's reading this global variable here, so it's not going to see the local color variables. Again, this is why I don't like to use globals, and why I kind of like that Python has this syntax, because you have to be very explicit and say, yes, I'm using a global variable here, yes, I want to change its value. It makes you at least know when I'm looking at this function that, okay, I'm dealing with this global color variable here. So that's why you have to do that. And same thing for the count down here. So I'm just going to say global count. And because I put this global count line in here, now this line right here is actually going to change my global count variable right there. Okay, so that's that. And then after this else if, I'm just going to call that update pixels function. So I'll just add that. And so that's, you know, basically I'm going to check which feed changed and then do whatever logic, like right here I parse out the color, or right here I parse out the count. These are going to change that global variable. Then they're going to call update pixels, and then update pixels is going to read those global variables and light up the pixels that color. At least in theory. Let's run it. Let's see what happens. Who knows? You know, I could have made a mistake, and we'll see what happens. Now when it starts up, remember, because I set these pixels to an initial kind of 0, 0, 0 value, and the count as 0, then, you know, we're not going to see anything when it starts up, even though my dashboard has some values here. So it's just kind of expected that you don't see anything. Okay, so I'm connected. So I'm going to change the count. Now nothing's going to happen because my color, remember my color is set to 0, 0, 0 still, because I haven't changed it. So now let's see what happens when I change my color. We'll go for like a pinkish purple. And hey, look at this. I have 2 purple pixels lit up. So let's see what happens when I drag this up. Then I get more. So I've got 8, go all the way to 10, go all the way down to 0, go up to like 6, change colors, do like a blue color, notice the changes there, go for like a bluish green kind of color, so that's cool, and then I can drag, you know, the pixels up. So cool, that's, you know, pretty much what I wanted to show here, that, you know, it's not too difficult to use Firmata with Circuit Playground to talk to your computer and then talk to internet services like Adafruit IO, for example. And we've got a great little system here where you can build a dashboard, put some controls on here and start making something that you're controlling over the internet. And like I could be, in another state connected to Adafruit IO, dragging sliders around and controlling my board. Because it's listening to these feeds, it's not my web page here directly connected to Circuit Playground. It's my web page here connected to Adafruit IO server, and then Adafruit IO server is connected to this little Python script that's running on my computer, and then that Python script is connected to the Circuit Playground board. So that's kind of what's happening, or how the messages are flowing around in the system here. So that's it. That's what I want to show in the stream. If folks have questions, throw them into the chat, and I'll see if I can get to them. I'll switch to the main view here real fast. And okay, yeah, just make sure I'm running okay on time. I think we're good here. So, okay, let's see. Is this Twitch painting? No, this is not Twitch painting. I'm not a robot. This is actually live. So if you're not familiar with Adafruit, so check out adafruit.com. We build a lot of electronics, kits and components, tutorials and things. We make electronics accessible to more people. So if you've ever heard of like Arduino or Raspberry Pi, some of those systems, we have a lot of things we build and teach people about to use them. Check out adafruit.com. Check out learn.adafruit.com. That's like our kind of learning system where you can see all the different guides and tutorials and things. So check that stuff out. We like Twitch though, so hey, I think there's a cool creative community here, and it's interesting. I think it's good when we get questions like, "What is this?" I've never seen electronics, so that's cool. Don't be afraid to ask stuff. Somebody wants to know, did you study any of this stuff, or did you just kind of learn it? I am a professional programmer. I went to school. I have a bachelor's degree in CS. But you know what? You don't need that to understand this stuff. And that's what I hope to show in a lot of these videos, that you can teach yourself this stuff. I've been kind of thinking that maybe later in the summer, I might do like a beginning Python series of videos. That could be a cool thing, like maybe 3 or 4 videos of just like starting from scratch, which is actually going to be really hard for me to do because, I've been programming since I was 13, over 20 years now. So all of this, is pretty natural to me. And so it's really hard when you know something pretty well to bring it down to a level that a beginner can understand. And so that's why I think it actually will be probably more challenging for me to do like a beginner theme stream than something like this where I'm just assuming that you've got some knowledge. But hey, don't let anything kind of hold you back or think like, oh, I'm never gonna learn how to do this stuff. Start simple, build on small things, and over time you'll be able to figure this stuff out. Okay, cool. Someone said, I'm so jealous I can't do this. No, you can do it. Trust me. This is, like I said, maybe a little more advanced of an example, and that I kind of assume that you know how like Python and Adafruit IO and stuff works. But subscribe to our channel, twitch.tv/Adafruit, youtube.com/Adafruit. We do all kinds of content. And like I said, I am kind of thinking that maybe I want to do some more beginner style stuff. Mostly because it's challenging, like I said, for me. I want to see if I can do it. And also because I think the audience out there would like it too. And let us know in the comments if you think beginner stuff is useful or you'd like to see that, then, we'd love to do it. So, and again, so if you like this stuff, check out twitch.tv/Adafruit. I stream a couple times a week. On Mondays, I like to do a Raspberry Pi quick look. And on Fridays, I like to do an in-depth series. And then I'm doing like a third stream now, like this one. So I'd like to do like Circuit Playground streams. So keep your eyes peeled. I'll do at least a couple streams a week. Now this week, my Friday stream, I'm actually going to move forward to Thursday. So tomorrow I'm going to do a new Pi stream. I just wrapped up the SQLite sensor storage series. So check that out if you're looking at like sensor data and Raspberry Pi. This week I'm going to start something new. I'm going to do something more of a project, and I think it could be kind of fun. So tune in tomorrow, and it'll be up on YouTube and stuff. You can watch it later. But check it out. I think this could be a fun one. It's going to be a long one. I think at least 4 parts, maybe more. But I'm revisiting an old project from my past, and I think we'll be able to build it better these days. So stay tuned for that. And then my Monday stream for next week, because of the holiday, it's July 4th, I think I'm going to probably push that to Tuesday next week. So I'll still do a quick look, but I don't think it's going to happen Monday. So hey, everyone enjoy your 4-day weekend or 3-day weekend, or maybe if you're unlucky, maybe a 2-day weekend. Or maybe you don't even have a 2-day weekend, but enjoy what you have this weekend, and hopefully the weather's good. Enjoy the holidays. So that's it. I think I'll wrap it up then. So like, comment, subscribe, let us know that you like these videos, and we'll keep doing them. That keeps us going here at Adafruit. So until then, this is Tony from Adafruit, and this was the Circuit Playground Firmata and Adafruit IO stream. So I'll see you guys later. Bye.